Hello, my name is Isaac Wachsman, and this is my open source contribution project video. So, the repository I was working on was Stan Math. So Stan is a probabilistic programming language used in research, statistics, and for developers. And Math is the particular C++ template library that implements many of the functions. So this is all written in C++. And my particular issue that I worked on was called vectorized logical functions, which was a good first issue and a new feature. And what they wanted to do was implement this set of functions that performed logical operators on essentially vectors. So you wanted to go through a vector component-wise and use a logical operator component-wise and return a vector. They also wanted to add these any and all functions, which are essentially a generalized or an and function, and also a generalized not function that performs element-wise negation. So I only had to add one file, which was vectorizedlogic.hpp. Because it was a new feature, I created a new file that didn't exist yet. I put it in fun folder, which stands for functions. So this is where a lot of the mathematical functions are implemented. And this is all my code, so it's actually 13 functions, and I'll explain what some of them do, but a lot of them are very similar, so I won't explain all of them. So they're all templated functions, so you can have a vector of pretty much any type you want here. And what this does is the logical equals takes in two vectors, it creates an output vector called result of the same size, then it loops through the vectors, and if the components that are equal, it'll put a 1 there, and if the components are not equal, it'll put a 0 there. So it returns a vector which basically contains the component-wise results of the logical function. So this is a logical equality. There's logical less than, greater than, less than or equal to, greater than or equal to. But when we get to here, we'll notice that this has the same name, so it's an overloaded method. The difference between this one is now this compares a vector and a scalar. So the logic is very similar, but this is using what's called broadcasting as described in the issue, which is that instead of comparing component-wise in two vectors, it compares component-wise in one vector to the scalar. So it has the same logic though, and I implemented those 5 functions again for broadcasting. Finally, there's these 3 functions here. What the logical not does is it takes in a vector, loops through it, and changes the sign of everything in the vector and returns it. And then any, like I said, is kind of like a OR function. So if there's anything that's non-zero in there, it will return a 1, or else it will return a 0. And for the all function, that's like a generalized AND function. So if there's anything that is 0, it will return 0, or else it will return 1. So I also wrote a main.cpp file that tests some of these, and I got the results I wanted. So the things that turned out the way I expected were that the repository was very easy to fork, and it was very easy to make a new file. I knew where to put it, and the code itself was very easy to write. So I know it's 13 functions, but the logic is very easy. The only thing I needed to brush up on a little bit was templating, because I forgot that a little bit from programming 2, but I was able to get this to work, so it performs on vectors of any data type. What didn't work as expected was that when I submitted my pull request, it seemed like I didn't do it right because I didn't have the correct testing framework. So this project actually uses some specific testing framework, and I submitted just like a main.cpp file, which showed that some of my tests worked, which was not what they wanted. So they wanted the specific testing framework, and I did not know how to use that one, so I wasn't able to submit that. So definitely in the future, I would read the documentation for the project well in advance to make sure that I have everything I need and that I know the correct testing procedures. So that's what I would do in the future. And that's all from my video. Thank you for watching.